Hello, friend. I'm glad you found your way here. The room is quiet, the lights are low, and your breath is already finding a slower rhythm. Tonight, we'll rest beside the sun, not too close, just near enough to watch its bright habits from a safe, sleepy distance. Our topic is simple to name and lovely to picture. Solar flares, the sun's soft fireworks. They're bursts of light and magnetism that bloom and fade. A storm that looks like a flower opening in fast motion. We'll move gently through how they spark, why they shimmer across space, and how their distant ripples sometimes brush our little world. No rush, no worry, just a warm guide through glowing weather on a star we know by heart. If this quiet keeps you company, a light tap on like and a soft subscribe. Help others find this calm corner too, whenever it feels right. For now, loosen your jaw, let your shoulders settle, and follow your breath as it lengthens. Imagine the sun exhaling, a bright petal drifting, and your thoughts going with it slower, lighter, calmer. Close your eyes. We'll begin together, unhurried, as the sky inside you grows still. The quiet face of morning makes the sun feel trustworthy, like an old lamp that never flickers. Yet under that bright comfort, it is busy in ways our eyes can't see. Currents of fire curl and fold, magnetic threads tighten like coiled springs, and energy gathers the way thunderheads do on a summer afternoon. When the strain becomes too much, the star exhales in a sudden, bright release. A solar flare, an outburst so intense it can rival billions of nuclear blasts at once. Yet it blooms and fades with the grace of a spark leaping from kindling. The surprise is not that these events happen, but that they are woven into the sun's ordinary life, as natural to it as waves are to the sea. Seen from Earth, sunlight feels smooth and steady, but the sun is not a solid thing. It is a vast globe of plasma matter, so hot that atoms drift apart into free-roaming ions and electrons. In this state, the gas conducts electricity as easily as a copper wire, and wherever charged particles flow, magnetic fields appear and move with them. Think of millions upon millions of invisible strings threaded through the star. Convection hot material rising, cooler material sinking tugs at those strings all day and all night, pulling, twisting, and knotting them until the tension hums. Sometimes the strings pierce the visible surface and dim it in small regions. We call those places sunspots. They look like bruises, but they're really footprints of magnetic power pressing through the skin of the star. Some are wide enough to swallow Earth several times over, darker only because they're slightly cooler than their surroundings, still hot beyond imagination. Sunspots come and go like seasons. Over roughly 11 years, the sun breathes through a magnetic rhythm. Activity builds, the spotted face grows busy, and flares become more frequent. Then the fever breaks, the surface clears, and the star rests in a gentler mood. In that same beat, the magnetic poles quietly trade places, north becoming south, south becoming north. An elegant flip that keeps the great machine cycling. The pattern isn't a metronome. It swells and relaxes with a living irregularity, but the rhythm holds, a heartbeat written in magnetism. It helps to picture the surface not as a smooth pane, but as a grainy, simmering field. Giant cells of rising and sinking plasma granules tile the view like a quilt, each one larger than a continent, each one lasting a few minutes before giving way to the next. Above that restless mosaic, bright arcs of material trace the paths of magnetic loops. They curve and glow like bridgework made of light, connecting one sunspot to another, arching out into the star's outer atmosphere. Where the loops tangle into tight braids, the stress builds. and then, in a breath, it lets go. That sudden letting go has a name that sounds tidy: magnetic reconnection. Two magnetic fields push against each other, lines of force pressed face to face in opposing directions, until the arrangement can't hold. The fields snap and rejoin into a simpler shape, and the stored energy pours out as if a deep knot had finally slipped free. In that instant, light spills across the spectrum, from radio to X-ray. Particles are flung to near the speed of light, and fountains of plasma rise into the corona like glowing surf. The scale is astonishing, but the principle is simple. Stressed fields, seeking a calmer geometry, and paying the cost all at once. It is easy to imagine all this happening only where we can see. But the sun's weather has height. Above the visible surface spreads the corona, the star's atmosphere, thin, ghostly, and strangely hot. Measured in millions of degrees, it outburns the surface below, a puzzle that has teased minds for decades. The best clues point again to those tangled fields, countless small bursts and braidings that leak energy upward, heating the airy heights where flares grow and travel. In coronas seen through special instruments, the sun no longer resembles the placid coin of daylight. It becomes a crown of filaments, plumes, and radiant threads, alive in every direction. For most of human history, none of this was more than a guess. To the unaided eye, the sun looked perfect, divine, even, and the idea of blemishes offended both science and story. Then a simple tube of glass changed everything. Early telescopes in the 17th century showed drifting marks. Galileo and others sketched them, watching their slow passage day by day. The sketches proved that the sun rotates and that its face is not flawless, but dynamic. Later, better instruments revealed detail upon detail. The fine granulation, the looping arcs, the quick flare-ups that come and go like lightning in fog. With space-age eyes, X-ray telescopes, ultraviolet cameras, magnetographs mapping the unseen, we now watch the sun like weather watchers on a storm coast, reading the swell and the wind to understand what is coming. What comes to us is usually gentle. Most flares do not trouble our days. Their light reaches Earth in 8 minutes, a swift whisper after a distant crack of brightness, and sometimes all they bring is a flicker on radio waves or a faint adjustment in the upper air. When larger storms follow, when the companion to a flare, a billowing cloud of plasma called a coronal mass ejection, sails our way, the effects can be louder. Satellites feel the push. Navigational systems wobble. Power grids sigh under strange currents. And in high latitudes, the sky writes in color. Auroras unfurl in green and violet curtains, a soft reply from our planet's own magnetic shield as it guides the storm toward the poles and turns particles into light. The same sun that grows a garden on your windowsill can, in rare moods, rattle the modern webs we've strung around the planet. That is not a reason for fear, it is a reason for attention. Scientists keep watch, with a patience that resembles prayer, listening to the radio hiss, measuring the crawling march of sunspot groups, mapping the flip and weave of the magnetic field. Forecasts emerge the way weather forecasts do, from patterns and probabilities, from new models tested against old storms. The work is humble and careful. A warning sent a day early can save a satellite from an ill-timed maneuver or a transformer from a quiet failure. Mostly, though, the watching gives us perspective, the reminder that we live within a star's reach, that space is not empty, but full of breathed-out sunlight. Under the science, the sun remains a story of pressure and release. Deep in the core, hydrogen meets hydrogen, merging into helium under a weight so great that the word heavy feels too small. The energy born there begins a long journey outward, thousands of years wandering, scattering, and scattering again until it finally steps into space as the warmth on your skin. The same energy stirs the convection above, and that motion stirs the magnetism, and the magnetism knots and snaps and lights the sky. The chain is grand and intimate at once. The heat in your cup of tea and the glow in an aurora both trace back to the same furnace. All the while, the solar cycle turns. There are years when the face is busy, freckled with spots, ringed with bright loops, flares coming like summer storms frequent, varied, some light, some strong. There are quieter years when the surface clears and the loops relax. In one part of the cycle, the poles prepare to trade places. In another, they settle into their new roles. The flip is invisible to your eyes, but not to the instruments, and the change ripples through the entire magnetic skeleton of the star. This rhythm has been tracked since the 19th century, its wax and wane a thread stitching centuries of notebooks to today's digital streams. If the sun's face is a weather map, then sunspots are pressure systems, and flare sites are the sharp lines where fronts meet. A cluster of spots signals a complicated magnetic layout below. Twisted ropes, sheared fields, crowded footpoints trying to share the same space. The more tangled the geometry, the more likely it is to lose patience. When reconnection begins, it does not creep, it rushes. Particles leap, light surges, bright ribbons trace new field lines across the surface, glowing where the energy has run. The event may last minutes or hours, but the rearrangement leaves a calmer field behind, at least for a while. From our distance, it can help to imagine sound where there is none. A flare is a chord resolved, a tight harmony finding an easier shape. The corona brightens as if lit from within. The surrounding loops sway and quiver, and then the scene subsides into a different order. Nothing is wasted. Even the particles hurled outward eventually soften into the solar wind, a steady breath that fills the space between planets and shapes the long tail of our own magnetic bubble. There are stories folded into the history of watching. One day in the 19th century, a sudden shock made telegraph lines stutter and the night sky blossom with color far from the Arctic. In the 20th and 21st centuries, a few well-aimed storms tugged at satellites and nudged grids, reminders that our technology has grown into the star's weather, the way old trees grow into wind. Each event teaches. Engineers learn to ground and shield. Operators learn to wait out a storm. Observers refine the signs that matter most. The goal is not to tame the sun, it cannot be tamed, but to share a language with it, enough to step out of the rain before the cloud breaks. Even the mystery of the hot corona is a kind of comfort. It tells us there is room for wonder inside the familiar, that the light filling every morning still holds questions worth asking softly in the dark. Tiny bursts called nanoflares may stitch the heat together from countless subtle snaps. Waves may carry energy upward along magnetic rails. The answer is likely to be many answers, humming together. That is how nature often works. Not a single trumpet, but a choir. The more you picture the sun as alive, the more its moods make sense. It has slow cycles and quick flashes, calm stretches and sudden weather. Its magnetism isn't an accessory. It's both skeleton and pulse. Its surface is not a shell, but a skin in motion. And its atmosphere is not thin air, but a bright meadow where fields curve and meet. Firework fits because flares are brief and brilliant and leave their patterns etched on the mind. Yet, unlike fireworks, nothing is thrown. The spark is self-made, tension gathered from within and released into light. Meanwhile, the daily, ordinary glow keeps pouring across oceans and fields. The same star that can set the sky dancing at midnight keeps your mornings simple and warm. Perhaps that's the deeper truth inside its restlessness. Stability is built from motion. The constancy we lean on is only the average of a billion small changes, each one settling the last. Even the 11 years we name is just a way to hold a pattern. The star does not count. It turns and breathes and flips and knots and shines. Close your eyes and imagine the sun not as a disk, but as a living sea. You can trace a loop from one spot to another. Feel the twist as flows carry the field sideways. Sense the silent instant when the geometry breaks and reconnects. Light races outward and arrives here in a heartbeat of cosmic time, brushing the high air, teasing a radio with static, hinting at color along the world's edges. It is near enough to read from your doorstep and far enough to remain a mystery. And while you picture that living sea, others keep a soft vigil, the way night watchkeepers once listened for changes in the wind. With telescopes tuned to X-rays and extreme ultraviolet, astronomers watch the sun shed its disguise. Loops of plasma reveal invisible magnetism like glowing threads on a dark loom. Before a flare, those loops twist tighter, too tense to hold until the pattern slips. Bright flashes run along the arcs, and a fountain of plasma lifts in great, luminous curves. Minutes pass, sometimes only seconds, and the tangle becomes light. What was stored as strain turns to radiance and heat, a sudden payment, energy falling cleanly into motion and glow. The beauty of this release is not limited to the Sunday. The same physics lives close to home. High above Earth, our magnetosphere meets the solar wind, two sets of magnetic fields facing each other, like currents colliding in a river. Where they press and shear, reconnection opens a door. Solar particles funnel through and hurry along magnetic lanes toward the poles. The upper air answers in color: green veils, violet edges, long red sighs, auroras that feel like a signature in slow, bright handwriting. In laboratories, smaller plasmas coil and flare inside machines that mimic pieces of the star. Scientists watch reconnection there, too, trying to tame it just enough to understand it and to guide it inside fusion reactors, where a captive sun might someday light our cities. The sun performs the same act at a scale that humbles the imagination. The stage is simply larger, the orchestra louder, the script the same. Where flares begin is seldom random. They grow from places that already wear signs of strain. Sunspots, the dark patches where magnetic field lines bundle and push through the surface. Astronomers call these places active regions because the name is honest. The field there is wound like an over-twisted spring. You can almost feel the ache in the geometry. When it unwinds, the release is swift. Energy runs outward through space, and the star brightens in ways that change with the kind of light you're using to look. To your eyes, a flare might be only a subtle brightening, an extra edge to a luminous patch that would be easy to miss without filters and care. Through X-ray telescopes, the scene turns electric. Bursts leap outward, loops glow as if drawn with a white-hot pen, and ripples travel across the corona like shock waves through a lake of light. Each wavelength tells a piece of the same story more than a flash, a spoken chord that spreads across space. Inside that chord, temperatures rise with startling speed. Plasma heated by reconnection can soar to tens of millions of degrees, hotter in the moment than the sun's core, which is saying something bold. Particles caught in the blast ride, magnetic roads outward and pick up speed until they near the cosmic limit set by light itself. Some of those particles reach Earth in minutes, disturbing radio links, urging satellites to fold into protective postures, tapping on the door of our technology like impatient weather. Others travel farther, slipping past us into the breadth of the solar system, tiny couriers carrying news from a storm we only glimpsed. The elegance here is quiet and deep. Nature leans toward ease. A hillside slides because a steeper incline is an uncomfortable pose. A lightning bolt stitches sky and ground because a charged cloud prefers peace to imbalance. On the sun, magnetic reconnection is the same search written in a different script. Tangled fields, reshaping into simpler lines, and the price of that simplification paid all at once in light. To call it violent is not wrong, but it is incomplete. This is a shortcut to equilibrium that glows. Studying such moments is hard in the way fast. Bright things are always hard. They arrive without much warning, run their course quickly, and throw their weight around in conditions we cannot build on Earth. That is why the unblinking eyes of spacecraft matter. The Solar Dynamics Observatory watches the sun in many colors at once, catching every flicker and loop. The Parker Solar Probe dives close, skimming the outer breath of the star, listening for how energy moves in the thin heat of the corona. Together, they gather the small details, the exact timing, the shape of a pulse, the way a loop shivers after it breaks, that let us make sense of flame on a star and translate it into a weather report for space. Under the measurements, there's a simple poetry that lingers. A flare is power released because invisible lines chose an easier shape. The mightiest star we know can be undone, for a moment, by a knot it tied itself. The sunrise in your window could come from the same being that, elsewhere on its surface, is throwing sparks high enough to rattle instruments across millions of miles. That contrast doesn't threaten the peace of morning. It enriches it. Stability is often a chorus of small storms averaged into comfort. Every flare starts small, a quiet tangle hidden from any casual glance, until the knot comes loose and the sky above a star lights in sudden defiance. Each one reminds us that restlessness is stitched into the universe. Not fussiness, not panic, just the steady urge to move from strain to ease. That urge writes its message across the full reach of light, and the message is rich. Light comes in a family of forms, from the long, slow radio waves to the shortest, fiercest gamma rays. The band our eyes call, visible about 400 to 700 nanometers, is a sliver, a narrow window cut into a great wall. We live most of our days inside that window. Sunsets, candles, the sheen on water, the pale blue of noon. When a flare erupts, the star sings well beyond it, and instruments become our borrowed senses. At the low energy end are radio waves, giants in length, running from centimeters to kilometers. During a flare, radio outbursts can last minutes or hours. They are not gentle murmurs. They can be strong enough to drown out Earth-based transmissions, to muddle navigation, to scribble on the air. To scientists listening with dishes and arrays, those bursts are maps. They show where particles are gaining speed, where plasma waves are moving, how the storm is arranged in depth. It is a kind of speech, crackling, spacious, informative if you know the language. Microwaves and infrared arrive next, not as dramatic to the public ear, but eloquent to those reading heat. They carry the thermal story outward, the way temperatures rise, plateau, and cool. the little afterglows that fade across minutes and hours as the plasma relaxes. Telescopes tuned to these ranges gather the clues of recovery, like hearing the breath slow after a run. Then comes the light we know, visible radiation. A strong flare can brighten the surface enough to be seen with careful, protected watching. These are white light flares, rare but unforgettable daylight, glittering on the sun itself as if a spark leaped from a bonfire. In the 19th century, observers with modest lenses recorded sudden flashes they did not yet understand. The physics would take time. The awe was immediate. Beyond the familiar sits ultraviolet, a borderland between what feels warm and what can sting. Flares flood this part of the spectrum, pouring photons into the sun's atmosphere, heating and ionizing gases that were already hot. Our planet's high air absorbs much of this energy, a kindness that keeps harm from the ground. From space, though, ultraviolet cameras see a different face, a restless tapestry of loops and arcs. During a flare, ultraviolet light spikes. The ionosphere reshapes. Radio waves skip differently. GPS grows fussy. Invisible light touching visible life. Climb higher in energy and X-rays greet you. These are signatures of particles pushed to extraordinary speeds. When fast electrons plow into denser layers, they flash X-rays in short, intense bursts. Spacecraft that watch in this band. GOES satellites. Among them keep a running tally, labeling flares by strength. C, M, X. A simple alphabet with real consequences. Those labels travel quickly to people who steer airplanes, watch over power grids, and tend satellites. A sudden surge in X-rays is a bell that rings loud enough to change a plan. Higher still are gamma rays, the top of the scale. They are rare in solar storms, brief and difficult to catch, but their presence tells of particles that have been pushed to the edge of physics, of conditions as extreme as a star chooses to make. The same instruments that listen for distant explosions in galaxies lend an ear to our own star for this reason. A flare that whispers in gamma rays is a reminder of scale, a small notation in a score that spans many octaves. Taken together, these wavelengths are not noise. They are the threads of a single event, woven from different colors of light. Radio waves show the roots of acceleration and the sway of plasma waves. Ultraviolet tracks the heating and reshaping of the atmosphere. X-rays reveal collisions, sharp and short. Gamma rays point to the most driven particles of all. With enough listening across the spectrum, researchers reconstruct the flare the way you might reconstruct a song from the parts played by each instrument. The distance millions of kilometers doesn't matter as much as the careful reading of clues. Under a blue sky or a quiet night, it's easy to forget that our days are tethered to a star sending messages on many channels at once. Small flares whisper across the band almost every day. Larger ones speak up every few weeks or months, a reminder that the sun keeps moods. We feel them more than we see them. A flight bending from the poles, a satellite pausing a maneuver, a grid operator watching a needle lean, a sudden aurora telling bright stories at the edge of the world. Thinking of flares as symphonies fits. An orchestra gathers strings, winds, percussion, brass. Each voice alone is lovely, but together they fill the air. A flare gathers radio, infrared, visible, ultraviolet, X-ray, gamma ray. Our instruments are the audience, with notebooks, leaning in, catching lines, writing the score as it unfolds. From this listening, patterns emerge that reach beyond our star, similar dramas in other suns, in giant planets' thin airs, Even in galactic hearts where fields twist on scales we can only name, the sun is generous. It performs close enough for us to study the brushstrokes, then use them to sketch the wider sky with a steadier hand. Sit with one flare, and light tells its story in many voices, some soft and passing, some fierce and bright, hinting that even the star we trust each morning has layers we're only beginning to know. Flares arrive in all sizes, quick flickers that barely stir the skin, and great outbursts that send ripples through the solar wind like stones into a dark, wide lake. To keep the music straight, astronomers lean on a small family of letters, C, M, and X. They look modest on the page, but they hold the weight of real energy. Each letter marks how much X-ray light a flare sends past Earth, a reading we cannot take from the ground because our air kindly keeps X-rays out. So satellites keep the watch for us, goes among them listening above the atmosphere and whispering when the first bright notes begin. The scale those satellites speak in is logarithmic, which is a gentle way of saying each step is not a step, but a leap. A move from C to M is not a shrug, it is a tenfold jump. A move from M to X is the same again. At the lightest end, class flares are the sun's small talk. They happen often, tapping the ionosphere just enough to shift radio paths a little and then are gone. The way a breeze dimples water without changing the day. They are useful reminders that the star is never still. Even on calm mornings, it simmers. M-class flares are the middle strength, 10 times the energy of C. The sort of event that makes radio operators listen harder and satellite teams pay closer attention. They can ripple communication at high latitudes and rouse auroras into brighter flow, especially when other solar weather joins the dance. Not disastrous, but not trivial. Either strong enough to matter to the people who keep our signals clean and our instruments safe. Then there are the X-class flares, the giants that bend the mind a little. The letter is only the beginning. Numbers follow to show how far the power climbs. An X1 is strong, an X10 is 10 times that, an X20 doubles even that reach. There is no wall at the top of the scale, only the limits the sun chooses. These are the events that can ionize the high air so deeply that radio falls silent across wide regions, that satellites slip into protective modes, that power grids feel strange, unwanted currents moving through their bones. For someone outside Earth's shield, an astronaut between worlds, the radiation from such storms can be dangerous. A reminder that space is beautiful and not always gentle. Yet even these fierce moments are invitations to learn. In them, physicists watch plasma and magnetic reconnection and particles driven to extreme speeds, all in a natural laboratory too large for our hands to build. Certain flares have written themselves into memory. On the 4th of November 2003, during the Halloween storms, one event grew so intense it swamped the X-ray detectors on goes, saturating them like a camera pointed at lightning. Later work suggested at least an X-28, perhaps more, an outburst whose particles raced outward, prodding satellites and nudging airlines to shift polar routes to spare crews and passengers extra radiation. In March 2012, the Sun offered an X5-4, part of a busy spell in solar cycle 24, that reminded everyone how quickly a quiet surface can tighten and burst into brightness. In August 1972, between Apollo 16 and Apollo 17, a powerful storm erupted. Had a crew been mid-voyage to the moon, the exposure could have been harsh. Timing, that time, was a kindness. Farther back, in 1859, Richard Carrington and Richard Hodgson sketched a sudden white light flare with their telescopes, a flash so bold that, within a day, telegraph lines sparked and auroras spread toward the tropics. We cannot pin a modern class to that event, but the Earth itself remembers. A scale like CMX does more than label. It turns chaos into something we can hold. It tells operators when to ground a long wire, when to rotate a satellite, when to reroute a flight. It gives us a way to speak about the sun's moods without losing the poetry of them. The letters are simple, the stories behind them are not. Instruments pushed to their limits, people working through the night. A planet wrapped in a magnetic field that usually keeps us safe and sometimes sings with light. Flares are only one part of the sun's temper. The other is slower and heavier. A true exhalation, the coronal mass ejection, or CME. If a flare is a flash of voice across the spectrum, a CME is the star lifting a portion of its outer atmosphere and sending it outward, a billowing cloud of charged particles, threaded with magnetic fields and expanding as it goes. The difference is like hearing thunder and watching the storm itself. One is sound, arriving at the speed of light. The other is the weather. Flares can reach us with their radiation in about 8 minutes. The time light needs to cross the space between us, and the Sunday CMEs take hours to days. They travel at hundreds to thousands of kilometers per second, fast by any earthly standard and slow only compared to light. And that delay is a gift. It lets space weather forecasters raise a hand in warning. It lets satellites turn and wait. It gives grid operators time to prepare. Sometimes a flare and a CME share a route, both born from the same tangled fields, and sometimes they part ways. A flare without a CME is a bright shout with no punch. A CME without a flare is a heavy wave leaving quietly. When they arrive together, the effect can be more than the sum of the parts. First, the light that changes the ionosphere and alerts our instruments. Then the mass that pushes against our magnetic shield. The sun does not time these for our convenience. We simply read them as best we can and get ready to ride them out. The scale of a CME is easier to feel than to count. Imagine a cloud weighed in billions of tons, growing until it is wider than the star it left, carrying within it the twist of fields that once were anchored to the surface. As it moves through the solar wind, it reshapes the flow around it, a tide carving its own channel. If that moving structure meets Earth's magnetic field with just the right alignment opposites facing, eager to reconnect, energy spills into our near-space environment. Currents travel through the upper air. The auroral ovals stretch. Particles spiral down along field lines toward the poles. The sky answers at night with green and red and violet, curtains that bend and sway like breath made visible. Underfoot, long wires and transformers feel slow surges that power systems were not built to love. In March 1989, such a geomagnetic storm darkened parts of Quebec, a reminder that the invisible can tug on the everyday. Predicting CMEs is the art of reading a living surface. Active regions come and go. Signs of strain build and relax. Even when a CME erupts, its path may miss us entirely, sliding past to brush some other world. When it is aimed our way, timing and strength still matter. A glancing blow or a head-on meeting, a weak field or one wound tight. Missions like SOHO and Stereo have shown us CMEs in flight, coronagraphs revealing pale, expanding halos that curl and spread. Images that look delicate at first glance carry practical information, speed estimates, directions, the evolving shape of the cloud so models can track its path and guess its arrival with enough confidence to be useful. In those pictures, The sun looks like it is blooming. In truth, a storm is unfurling. Flares and CMEs share the same source code, magnetism shaped by motion. The sun's field is braided by flows and sheared by differential rotation, tightened by emerging ropes of plasma, and relaxed by reconnection. The same rules that let a flare light the corona also let a CME lift away. And those rules repeat across the cosmos. Other stars flare, some far more often than our own, some with a violence that could strip a close world's air and scatter its chances for life. Giant planets glow with auroras drawn by their magnetospheres. Even galaxies grind their fields in environments where gravity, rotation, and plasma write a larger, stranger script. Our star is a nearby teacher. The lessons travel. Earth is not the only student in the solar classroom. Mars feels storms keenly, its thin air and weak field offering little shelter. Over ages, solar weather has helped lift its lighter gases, a slow theft that changes the story of a planet. Other worlds have their own responses. Jupiter's vast magnetosphere, swallowing solar gusts and answering with auroras fit for a giant. Mercury, with almost no air to speak of, enduring direct sculpting of its surface by the sun's breath. When we think about life elsewhere, we think not only about warmth and water, but about the temper of the parent star, how often it flares, how wild its CMEs, whether nearby worlds have shields enough to keep their skies. The classification of flares C, M, X folds neatly into this larger weather. A class day is the sun whispering. An M-class burst asks for a bit of care. An X-class roar is a signal to fold delicate things and set them aside for a while. None of this removes the wonder. It simply lets wonder share a table with preparedness. Radios may crackle, GPS may wander, a long wire may hum, but the night sky may also lift its colored drapes for people who rarely see them. On certain evenings, after a storm has spent itself, photographs from unexpected latitudes appear: farmhouses under green rivers of light, city edges washed with purple, children in winter coats staring upward for the first time. History's notes help, too. The Carrington sketch, the 1,972 near miss for Apollo, the 2003 saturation during the Halloween storms, the 2012 reminder that the cycle's quieter years can still flare bright. Our tools are better now. Magnetograms mapping the sun's skin, helioseismology listening for flows below the surface, coronagraphs catching the faint outline of a departing cloud, spacecraft that taste the solar wind directly, measuring its density, speed, temperature, and field. Each advance turns guesswork into guidance. Each warning sent in time turns worry into watchfulness. The difference between a flare and a CME stays simple if you hold one image for each. The flare is the flash the sun's voice across the spectrum, from radio to gamma rays, reaching us at the speed of light. The CME is the shove the sun's hand on the solar wind, a moving mass threaded with magnetism, arriving hours or days later and changing the shape of our near-Earth space for a while. Often they walk together. Sometimes they don't. Either way, the same restlessness threads them both. Numbers can steady the mind without making it heavy. Light takes about 8 minutes to cross the space from Sun to Earth. CMEs cruise anywhere from a few hundred to a few thousand kilometers each second. X-ray classes climb by 10C to M to X with X1, X10, X20, marking how high the crest rises. A single CME can carry billions of tons of plasma. On rare days, a storm can reach across the magnetosphere, and tug slow currents through long lines on the ground. Up there, a timely forecast lets a satellite live to work another day. Down here, a mindful grid bends without breaking. And at the edge of night, a town that has never seen an aurora may shuffle outside in coats and whisper at a sudden river of green. Beneath the figures runs the same quiet truth. The sun is steadiness, made from countless changes. Classifications give us clear words. Images give us eyes. Models give us practice. The rest is feeling the sense of living under a star that is both shelter and story, warmth and weather. C, M, and X are notes on a page. The music itself is played in light and charged particles, in fields that cross and reconnect, in clouds that lift and drift outward. Somewhere above the bright surface, a new loop is gathering slow as a breath. Somewhere else, a field is tightening, almost ready to slip into a simpler shape. Instruments keep their soft vigil, listening the way one listens for rain in the distance. The room stays calm, the night stays kind, and the sun keeps at its patient work. Flash and wave, letter and number, whisper and roar, each part moving through us and moving on. In that listening, two moods begin to feel like one story. Picture the flare and the CME as different expressions of the same magnetic thought. One is light itself, quick, bright, a blaze that runs through every octave of the spectrum. The other is weight and motion, a rolling tide of star stuff pushing outward on its own momentum. Each alone is striking. Together, they remind us our daylight companion is not a clock on the wall, but a living neighbor with weather, temper, and breath. Their mischief can rattle careful machines, and yet they also paint the night with tender, unlikely colors, enough to bring people to their porches in the cold and make them forget for a minute to speak. When the flare begins, the energy does not stay folded inside the star. Light leaves it once and crosses the 150 million kilometers between Sun and Earth in a little more than 8 minutes, lighting up the high air with X-rays and extreme ultraviolet. Along the same paths, showers of charged particles follow, some quick, some late, sometimes joined by a slow, enormous wave of plasma. The coronal mass ejection. Our planet doesn't meet these visitors naked. It carries a veil and a shield, and together they change a cosmic storm into something we can mostly live with and sometimes even enjoy. The shield is the magnetic field, born deep in the planet's liquid outer core and stretched outward into the magnetosphere. Imagine an invisible cocoon pushed into a teardrop by the constant breath of the solar wind, compressed on the day side, flowing into a long tail on the night side. This cocoon deflects most of the sun's charged particles, steering them around us or down the rails that bend toward the poles. Without this guard, the wind would work on our air the way it has worked on Mars, molecule by molecule, year by patient year, thinning what life needs. Light arrives first. X-rays and extreme ultraviolet meet the ionosphere, those lofty layers where thin gases become electrically charged and they add more free electrons in a rush. For a while, radio waves that bounce through that region find new paths or lose their way. As if the sky had been tuned to a noisier station, long-distance signals grow scratchy. Pilots and radio operators feel it immediately. Instruments that usually hum with certainty grow hesitant, and a voice that should be clear turns to static. If a CME is coming too, the quiet becomes a drumbeat. Hours or days later, the cloud threaded with the sun's own magnetic field reaches the magnetosphere and strikes. The shield ripples and compresses, Field lines bend, twist, and reconnect. Energy spills into the upper air, and a geomagnetic storm begins. The planet answers with light and with currents, with beauty and with work. At the poles, charged particles spiral down along field lines like beads on wires. They collide with oxygen and nitrogen between roughly 100 and 300 kilometers above the ground. The atoms take the energy in, then let it go as color. Oxygen gives the familiar green that flows across most displays. At higher altitudes, when the air is thinner and the time between collisions grows, the same oxygen can release a deep red, a rare wine-colored edge that startles even people who have seen 100 auroras. Nitrogen glows in violets and blues, often flickering along the folds. Lines become curtains, curtains become rivers, and the sky looks like wind moving through silk. For those who live beneath the auroral ovals, Alaska, northern Canada, Scandinavia, the lights are part of the year's rhythm. Children learn to look up the way others learn to look for rain. During strong storms, the ovals swell and spread. Colors reach into places that rarely see them. Old journals speak of nights when red light glowed near the tropics, and telegraph operators felt heat in their keys. The surprise of it hasn't faded in a century and a half. When the curtains wander south, city people step outside and stare at a sky they thought they knew. The same currents that paint the sky can travel through ground and metal. Long wires act like antennas. Power lines and pipelines collect slow surges they were never designed to welcome. In March 1989, a CME sent such a rush through Quebec that transformers tripped and the grid went dark for hours. Streets fell quiet, and people learned a new phrase, space weather, because a storm on the sun had rippled through the bones of a modern city. The lesson wasn't fear, it was awareness. Grids can be hardened, transformers can be guarded, operators can choose to carry a lighter load when a storm is on its way. Above the air, satellites feel the storm in different ways. The upper atmosphere warms and expands, raising the air drag on spacecraft in low Earth orbit. Paths that were tidy become messy, and operators must correct orbits more often. Navigation satellites, our everyday compass, send signals that pass through a disturbed ionosphere. For a while, positions drift, and the familiar blue dot on a map hesitates. Surfaces can charge electrically, building tiny storms of their own on solar panels and skin. Most of the time, the fixes are simple. Change mode, turn a face away, wait it out. But the timing matters, and the warnings do too. For people in orbit, storms are personal. When the sun grows loud, astronauts on the International Space Station move into better shielded sections until the numbers fall again. Future crews headed beyond Earth's magnetic umbrella will need a deeper plan. Shelters inside their ships, forecasts they can trust, quiet places to wait while a storm passes. Airlines already fold the sun into their routes. High-frequency radio over the poles can fade during strong events, and the air at those heights carries a little extra dose of radiation. Flights sometimes take lower latitudes, instead longer, calmer paths that keep crews and travelers well inside the planet's protections. The puzzle is that no two storms are quite alike. Some flares whisper and pass. Some CMEs wander off into space and never meet us. Others align, just so fields pointed in the wrong direction for us. And the transfer of energy into our magnetosphere is swift and efficient. Terrestrial weather gives us clouds we can watch rolling over a hill. Space weather arrives from the far side of the sky, and the shapes are magnetic, not visible. That's why sentinels hold their posts. Soho watches from a steady point in space, catching the faint outlines of CMEs as they lift and expand. Stereo's twin perspectives taught us how those clouds spread and where they are headed. Other spacecraft sit upstream in the solar wind, tasting it directly: density, speed, temperature, field, so warnings can carry numbers rather than guesses. Minutes to hours can be enough to turn a satellite, to shift a load, to choose a different path across the ocean. The distance never stops being humbling. A star, 150 million kilometers away, loosens a knot in its field, and the change travels through light and wind until radios crackle, compasses wander, and the sky writes in green. The scale is huge, but the response is human. Measure, plan, adapt. The magnetosphere deflects and stores. The atmosphere glows and protects. Engineers add margins, operators keep watch, and the rest of us catch our breath at the edge of a field, while the curtains of color ripple overhead. There's an old poetry to all this that people felt long before the numbers were known. Cultures close to the poles told stories to meet the lights halfway. Sami families moved with care under the glow, speaking softly as if not to wake a sleeping spirit. Inuit tales pictured games in the sky, souls tossing a skull that flashed and faded as it turned. Norse imagination saw reflections from shields and spears, a warrior's shimmer thrown up against the cold. In other times and places, scarlet nights were read as omens. Meanings changed with language and century. The awe was the constant. Understanding hasn't washed the magic away. If anything, the physics deepens the feeling. Each flicker is a particle that left the sun in a storm, rode the wind for days, found the rails of our magnetic field, and met an atom in the thin air high above us. The light you see is the end of a long trip, the last syllable of a story that began in a knot of fields on a surface you can't stare at directly. To witness it is to be present at the finishing line of a race that ran across space. The aurora is not a still painting. It breathes like a living thing. Sheets fold over sheets. Spirals coil and unfurl. Bands that were smooth become braided and then smooth again. Sometimes it brightens so fast that the ground seems to answer. Sometimes it fades into a soft haze and then returns with a sharp edge of violet like a whispered laugh. No two nights match, and even in one evening the sky can rehearse a dozen styles. What you are seeing is the magnetosphere doing its own reconnection field lines, snapping and joining. Energy moving from one form to another, translated into color. For scientists, those lights are more than a show. Cameras on the ground and in orbit, magnetometers, radio arrays, all take notes as if the sky were a dashboard. The shapes tell about the geometry, the speed of the solar wind, the strength of the field that arrived, the way energy flowed into the tail and back toward Earth. Models sharpen, forecasts improve, and warnings land on the desks of people who can use them. Not every storm makes a headline. Many bring nothing more than a touch of noise in the ionosphere and a faint edge of green near the horizon that only a camera can find. Others test the seams of our systems. The difference is sometimes a matter of alignment, sometimes of timing, sometimes of simple luck. We can't steer the sun, but we can grow fluent in its moods, ready to protect a satellite, steady a grid, or point a lens to the north when the numbers say the curtains may appear. There's comfort in the balance. A star breathes out light and plasma. A planet shaped by iron and stone answers with a magnetic field and sky. Our machines, delicate by comparison, learn to bend rather than break. Most nights pass with no sign at all. Sometimes the sky speaks. On those nights, a town that has never seen such color might stand in driveways and fields, Phones tilted upward, faces washed in a green they have no name for. Far away, operators in dim rooms watch graphs that settle after a long climb. A pilot glances at a different route drawn across the map. On the station, someone floats in a quiet module and listens to the numbers drop. To live here is to live inside the sun's weather, not as victims, not as masters, but as neighbors who know when to close a gate and when to stand at the fence and watch the horizon. Light will always outrun us. CMEs will always take their time. The magnetosphere keeps its teardrop shape pressed on the day side, flowing into a long tail at night. Oxygen glows green, high oxygen, sometimes red. Nitrogen laces the edges with blue and violet. Wires hum a little when the field swells. Radios complain, then clear. The cycle continues, old as our world, steady in its restlessness. If the lights show tonight, and maybe they won't, you'll be seeing the end of a long chain of quiet causes. If they don't, the chain still ran, the way a heart runs while you sleep. We learn the signs, make room for them in our plans, and when the sky decides to paint, we step outside, follow the curve of field lines toward the poles, and let the colors say what it has always said. We live inside a moving, breathing cosmos, and beauty arriving sometimes on the heels of trouble knows how to find us. Most nights, the world below goes on as usual. Phones buzz, ovens hum, streetlights glow. If a storm from the sun has arrived, most of its fuss slips past unnoticed, leaving only a gift for anyone who looks up. A strong aurora can quiet a crowded mind in a heartbeat. Under a sky threaded with shifting greens and sudden pockets of crimson, you feel smaller and somehow roomier at once. The air above is busy with energy that began 93 million miles away and was reshaped by Earth's invisible defenses into curtains of light that fall without a sound. The show is intimate, a soft glow on your cheeks, and grand, spanning the horizon. Not a separation of Earth from the cosmos, but a stitch, a place where sky and star breathe together, and the seam shows itself just long enough to make you still. There's a kind of gentleness hidden in the aurora's origin story. What starts as turbulence in the sun's tangled fields, twists and knots of magnetism pressed too far, becomes light that drifts across silent forests and cold seas. The same physics that can trouble a satellite or flicker a radio also paints color into the night. Chaos gives way to grace, disruption to wonder, as if the universe were showing both sides of its face in one gesture. When the lights appear, they aren't only pretty. They are a whisper from the sun, telling the long route of a storm, a knot loosening, a wave crossing space, a meeting with Earth's shield, and then the sky answering in luminous fabric. To look at them is to see the invisible, made visible, the breath of a star, caught in a net of magnetism and woven into a moving cloth. One morning in late summer of 1859, Richard Carrington stood at his telescope, a careful observer tracing the dark islands of sunspots. The sun was in one of its restless moods, and Carrington had grown used to the daily ritual of sketching. Then the unexpected. A sudden burst of brilliant white light flashed across the spots, too bright and clean to ignore. He didn't have a name for it yet, but he had done something no one had done before, watched a solar flare directly with human eyes. Hours later, Earth felt the consequences of what he had seen. The first wave was light X-rays and extreme ultraviolet, disturbing the upper air. Then came the mass, a coronal mass ejection, a cloud of plasma and magnetic field, thrown outward at uncommon speed. When it reached Earth, the impact was astonishing. From the high latitudes down toward the tropics, Auroras unfurled in greens, violets, and a red so deep it startled people who had never known the sky could do that. Reports said the glow was bright enough to read by. In the Rockies, miners rose in the small hours, convinced dawn had come, and set coffee to boil. In Caribbean waters, sailors stared as sheets of light rippled over the horizon. The beauty came with a bite. Telegraphy was the wonder of the age. Copper stretched across continents, messages beating horses and ships for speed. As the storm pushed and pulled on Earth's magnetic field, currents were induced in those long lines. Operators watched sparks leap from their keys. Some felt shocks. A few discovered that, with batteries disconnected, the instruments still carried words, powered by a storm born on the Sunday. One Boston operator wrote of great shocks and sparks flying in every direction. There were small fires, damaged lines, a network stumbling under a force it couldn't name. The same event that broke the system also revealed the reach of natural electricity. People learned, in a vivid way, that the sun's temper could stretch across space and touch human tools. The Carrington event remains the benchmark, the fiercest geomagnetic storm in our record. Its meaning grows each decade. In 1859, the web of technology was thin and mostly on the ground. Today, our world is stitched with delicate threads. Satellites circle overhead carrying navigation, weather, communications, and timing. Grids spread across countries and continents. Undersea cables link far shores. Markets depend on clocks that stay in step to the split second. A storm of Carrington's scale in this century would be a global exam. The questions are practical. How much current would flow in long lines? How many transformers could shrug? And how many might fail? How many months would it take to rebuild the parts that cannot be fixed with a wrench? It's not drama to imagine that such a storm could reach into logistics and hospitals, finance and farming, because each depends on power and precision in ways we forget until they flutter. This is why Carrington's morning still matters. It is the story scientists use when they ask what modern systems can endure. Studies of power grids show that those long, efficient lines are also wide windows where geomagnetically induced currents can enter. In a storm that strong, transformers could saturate, overheat, and fail in ways that require replacement, not repair. Replacements for the biggest pieces are not kept like spare bulbs. Building and installing them takes time. In orbit, satellites would face surges of radiation, surface charging, and panels losing efficiency under a flood of particles. GPS could wander, communications could blur, networks that rely on flawless timing could stumble. The scenario is sobering because it is specific. It lists all the things we've placed between ourselves and silence. The record since 1859 carries other reminders. In July 2012, the Sun threw a massive CME that missed us by a matter of days. Earth had been in that very track a week earlier. Had the timing aligned, our instruments might have woken, as the Victorians did, to a world behaving oddly. Satellites asking for help, grids on the edge, flights on new paths, operators reading graphs that dipped and surged. A near miss isn't nothing. It is a rehearsal without an audience. Before that, in March 1989, a storm rooted in a more ordinary outburst still managed to pull Quebec's grid into darkness for 9 hours. Operators worked by lamplight. The event was not Carrington's scale, yet it gave a glimpse of how quickly a complex system can slip. Even the deep past speaks, not in diaries, but in the chemistry of ice and wood. Tree rings and polar ice hold traces of unusual cosmic ray showers. with signatures around the years 775 and 993 that suggest extreme solar activity. Those hints tell a broad story. The sun's capacity extends beyond what we've measured with modern instruments. We cannot assign them neat classes or timelines, but they remind us that our star has a long memory and an uneven temper. Between Sun and Earth, a chain of watchkeepers now stands. The Solar and Heliospheric Observatory watches the faint halos of CMEs as they leave the corona. The Solar Dynamics Observatory captures the Sun in many wavelengths at once, revealing the loops and ribbons in exquisite detail. The Parker Solar Probe dives close enough to taste the Sun's outer wind and send back what it learned. At the L1 point, about 1.5 million kilometers sunward, upstream monitors sample the solar wind's speed, density, and magnetic orientation, offering warnings in minutes instead of surprises on arrival. Those minutes matter. They can be the difference between a satellite riding out a storm in a safe posture and a mistake that shortens its life. They can give a grid time to shift load or isolate a vulnerable section. They're small kindnesses couched in numbers and alerts. Even so, prediction remains a delicate art. Hurricanes unfurl across water with shapes we can see. CMEs lift from the sun with little warning. And the finest detail, the orientation of the embedded magnetic field, when it finally reaches us, can be decisive and is hard to read from afar. The models grow better each cycle, the instruments sharper, the partnerships steadier. Yet the honest line is this: there will be storms that surprise us. We are less at the mercy of the sun than we once were, but we are not beyond its reach. It helps to keep both sides of the story in view. Down on the ground, most disturbances pass as ripples no one feels. A sensitive radio might complain, a satellite planner might frown, a distant aurora might faintly dust a horizon no one is watching. Then there are nights when the world notices. Curtains climb and fold. Colors creep south. People who have never seen such a thing gather in parking lots and back fields, faces tilted, voices lowered without knowing why. They take pictures with numb fingers. They try and fail to find words that make the shimmer ordinary. The lights do not cure anything or fix the day's worries. They simply invite you to stand still for a moment and remember that your weather includes the Sunday. Carrington's legacy lives in the way we prepare. Utilities study their networks and reinforce the pieces most exposed to slow surges from the ground. Satellite builders design for charging and radiation. Operators build playbooks for storms, procedures that move quickly without panic. Airlines weigh routes and altitudes with space weather in mind. Forecast centers issue notices as quietly as any other weather bureau, and most days, those notices become nothing more than good practice. On some days, they become the difference between a story told later with calm and a night spent guessing in the dark. The human part of the tale is easy to picture if you close your eyes. A miner in the Rockies that 1859 morning, waking to a light that shouldn't be there. A telegraph operator rubbing a stung wrist and watching the key spark. A sailor in warm water seeing colors he never expected to find above the sea. A grid operator in 1989 leaning into the desk as the numbers slope the wrong way. A scientist in 2012 reading the data from a storm that missed us, feeling a gratitude that is also a nudge. The line that ties them together is not abstract. It runs from a star's breath to a human heartbeat and back again. For all its trouble, the sun is not hostile. It is merely alive by the rules it has always followed. It knots and loosens. It shines and storms. It sends light as a habit and particles as a mood. Our planet answers with a field shaped like a teardrop and an atmosphere that glows in reply. Our machines learn to duck. Our eyes learn to widen. The balance is not perfect and never will be. It's a living balance, made of give and take, built from preparation and awe. If another large storm comes, and someday it will, the sky will carry both the warning and the consolation. Instruments will speak first, crisp little paragraphs of numbers and arrows. A few hours later, the horizon might flicker. The colors will rise, perhaps where you've never seen them before. Somewhere a transformer will hum harder than it should. Somewhere, too, a child will tug a sleeve and point upward. Somewhere, a pilot will take a longer path that keeps a cabin safer. Somewhere, on the station, a small group will sit in a protected module and tell stories while the counters tick down. These are all the same moment, seen from different rooms. Most of the time, the storm passes and the world returns to its usual rhythm. The lights dim, the ionosphere relaxes, the magnetosphere's tail straightens and streams. Power lines shed the strange tingle they carried. People go back inside. A few will check the photos they took and find that the camera caught colors their eyes missed. Some will read about the sun the next morning over coffee. And overhead, the star will keep its work, its fields winding and unwinding, a patient choreography that, now and then, reaches across space and lays a trembling hand on our sky, soft enough to be beautiful, strong enough to ask for our attention, steady enough to keep us warm while we listen. The thought of another storm on the scale of Carrington lingers like distant thunder, half scientific puzzle, half civic worry. Engineers sketch quieter transformers that won't drink up slow underground currents. Grid planners test ways to segment power networks so one region's trouble doesn't cascade into darkness. Satellite designers weave radiation-hard parts and safe-mode habits into machines that circle above the weather. Policy teams weigh stockpiles of critical spares and the cost of building redundancies that, on most days, sit patiently unused. Progress happens, then pauses, pulled by budgets and nearer emergencies. Meanwhile, every strong solar disturbance that brushes Earth becomes a gentle rehearsal, a reminder that our calm daylight is sustained by a star with moods. For most of us, space weather feels abstract compared with rain on the window or heat in July. Yet the near miss of 2012 stands close enough to touch, a massive coronal mass ejection crossing the exact lane Earth had occupied a week earlier. Imagine waking to a thinner world, GPS blinking uncertainly, cell towers talking to no one, banking networks out of step because precise timing lost its footing, parts of the grid flickering or gone. It wouldn't take long for small inconveniences to braid into real knots. None of that belongs to fantasy. It is a natural hazard written into the biography of our planet and the temper of our star. Near misses offer twin gifts: relief that this one sailed wide, and a clear whisper that fortune is not a plan. High above clouds, past the tender blue edge of air, a quiet fleet keeps watch. They do not blink, they do not sleep, and their work folds science and safety into the same breath. We lean on them more than most of us know. A flare can bloom in minutes. Its light arrives in roughly 8. A CME takes longer hours to days, but once the cloud has lifted from the corona, the clock is counting. With warning, operators can lighten grid loads, airlines can bend routes away from the poles, satellites can turn their faces and enter quieter modes, crews in orbit can move into the most shielded corners. Without warning, we are living the first chapter as we read it. One steadfast sentinel has been on duty since 1995. The Solar and Heliospheric Observatory, set at the Sun-Earth L1 point about 1.5 million kilometers sunward. From that perch, SOHO has watched the corona unfurl and has captured the pale halos of CMEs as they billow outward. Its coronagraph images, sunlight-masked, faint structures revealed, let forecasters estimate speeds and directions, turning mystery into hours of lead time. Closer in spirit to a magnifying glass, the Solar Dynamics Observatory has, since 2010, given us the sun in exquisitely sharp extreme ultraviolet, showing arcs and ribbons, sunspots brewing like knots under skin, bright footpoints where magnetic lines snap and reconnect. SDO's constant stream of images doesn't simply please the eye, it feeds models that tie cause to effect. Then there is the daring Pathfinder, Parker Solar Probe, launched in 2018, diving into the sun's outer atmosphere again and again. Each pass is faster and closer than the last, well over 430,000 miles per hour at perihelion, protected by a heat shield that turns furnace into survivable day. Parker tastes the plasma and magnetic fields in the very place where the solar wind is born, answering questions that puzzle generations. Why the corona runs hotter than the surface below, how waves and reconnection push particles to such speeds, which structures carry energy outward and which merely glow. Add the twin perspectives once offered by stereo, which taught us how CMEs spread in 3 dimensions. Add Solar Orbiter, launched in 2020, angling for rare looks at the sun's higher latitudes and the mystery of its poles. This watch is a chorus, not a solo. Hinode from Japan has sketched the fine grain of magnetic fields. India's Aditya L1 has joined SOHO's lane to look sunward from the same strategic point. Ground telescopes, like the Daniel K. Inouye Solar Telescope in Hawaii, trace hair-thin filaments and tiny jets that together may heat the corona more than any one flare can. The data flows inward to forecasting centers, the Space Weather Prediction Center in the US, ESA's Space Weather Coordination Center in Europe, and partners worldwide, where it is sifted, modeled, and translated into alerts for people who drive airplanes, shepherd satellites, steer grids, and time the world's trades. Space weather doesn't ask for passports. Collaboration outruns competition because storms do. What makes these guardians compelling is as much their philosophy as their hardware. We cannot quiet the Sunday. We can, however, become good listeners and timely responders. Each spacecraft is a lighthouse on the solar sea, sweeping a beam across waters we cannot sail, calling down, something is moving. Set your lines, take in a sail. The images they send are more than warnings. They reveal a star, alive in 1,000 motions loops, arching higher than Earth's diameter. Shock fronts that look like invisible tsunamis, spicules lancing upward like grass in a wind you cannot feel. To watch is to understand that daylight's innocence is woven from fierce physics, and that our peace is not the absence of motion, but its careful averaging. The question that lingers is quiet but insistent. Will we be ready when chance stops favoring us? Readiness looks unglamorous up close. It is transformer cores designed to resist saturation. It is spare parts bought years before they're needed. It is satellites with thicker skins and habits of turning aside during storms. It is ground procedures rehearsed until they feel like muscle memory. It is international agreements that keep upstream monitors funded and healthy. so a line of numbers continues to flow from L1. It is also education pilots who know why a route might arc south tonight, operators who trust the forecast enough to shift the load now rather than regret it later, citizens who understand that auroras and advisories can share a sky without contradiction. Beyond hardware and policy, the story reaches into human bodies. On the surface, we are wrapped by a magnetic field and an ocean of air. We seldom think about either. Astronauts live nearer to the edge. The International Space Station, circling roughly 400 kilometers above Earth, still rides inside much of the magnetosphere's protection, but the shield is thinner there, and instruments on the station tick a little faster when the sun grows loud. Crews have practiced rituals, moving into denser, better protected modules, often near water supplies and equipment, that, by happy design, doubles as shielding, waiting for readings to settle. Even so, radiation accumulates over months, raising lifetime risks in ways planners track closely. The real test lives beyond the cocoon. Apollo crews were lucky history's great, kind roll of the dice. In August 1972, a powerful solar storm erupted between Apollo 16 and Apollo 17. Had a crew been coasting to or from the moon then, with only aluminum and belief between them and space, the dose could have been grave. Deep space travel reopens that question with sober eyes. Protons and heavier ions from flares can arrive within minutes to hours. Galactic cosmic rays are fewer, but more penetrating. A long rain that never entirely stops. Shielding becomes both architecture and strategy. Storm shelters inside spacecraft where water, food, and equipment are arranged like bricks to thicken the wall. Lunar habitats draped in regolith, tanks and cargo stowed, so they will serve two purposes: keeping crews alive in routine days, keeping them safer when counters rise. Mars stretches the challenge. Months to get there, months to get back. A thin atmosphere above a world with only remnants of a global field. On the transit, the vehicle is the planet. Its design decides the weather inside. Mass is a tax, and launch costs make every kilogram a debate. So engineers thread the needle. Local shelters, rather than whole ship armor. Materials that stop charged particles without breeding too much secondary radiation. Layouts that put sleep and work where shielding is naturally thickest. Some research reaches for more radical means. Active magnetic shielding to imitate Earth's protection. Plasma bubbles to deflect charged streams. But those ideas are tender still. What is not tender is the need for warning. Upstream monitors give hours, sometimes minutes. That may be enough. Stop the EVA, stow tools, retreat into the quiet place, close the hatches, wait as long as it takes. Radiation's risks wear two faces. The long one is statistical cancer. Years later, cataracts, changes that build silently. The short one is immediate. Doses high enough to make a person ill, to fog decisions, to threaten tissues that won't heal in time. In the small rooms of space, with medical care limited and help far away, planners approach the problem with a humility that sounds like courage. Training bends the fear into protocol. Shelters become familiar, not ominous. The invisible becomes a number on a screen that everyone knows how to read. If this seems stark, consider the comfort braided into it. Strategies already exist and have been proven in parts. The ISS has taught lessons in monitoring and layout that apply far beyond low Earth orbit. Designs for lunar bases fold shielding into walls and floors, with regolith piled above like a thick blanket. Mission profiles for Mars carry storm shelters as a given, not a luxury. and power systems built with redundancy, so waiting out a 2-day storm doesn't strand a crew. Each rehearsal on Earth, inside labs and vacuum chambers, under particle beams, makes the future a little steadier. Back on the ground, the societal work continues. Utilities plan for sectionalizing the ability to open and close parts of the grid so a surge doesn't race across a continent. Operators simulate worst-case days until their hands know what to do next. Communication companies design satellites with higher fault tolerance and constellations that can lose a few members without losing the service. Financial systems look for more than one clock, so a hiccup doesn't ripple into mispriced trades. Meteorologists of space weather refine models that turn SOHO's faint halos and SDO's bright loops into practical sentences. Arrival expected, field likely southward, take precautions. The global character of this vigilance matters. Spacecraft at L1 serve everyone downstream. A flare does not care about borders. Instruments in one hemisphere can watch while night covers the other. Data flows through agencies and universities and companies, and the picture sharpens when no one hoards a piece. There is quiet dignity in the fact that a camera in Hawaii and a magnetometer in Finland and a dish in India can help an airline over the Pacific and a grid in South Africa on the same night. This is what shared weather looks like at planetary scale. Even so, preparedness must live with uncertainty. CMEs don't give us slow, photogenic spirals to study as they cross an ocean. They lift, and they're gone. And what matters most, the orientation of their embedded magnetic fields when they reach us, can be hard to read until the cloud is near. Our models grow more faithful with each cycle. Our monitors more sensitive. Our habits more practiced. The honest glimpse is that we will still be surprised. The sun will still choose its moments. The most we can do is to make sure those moments meet a world that has rehearsed. It helps to ground this in the ordinary. Most storms do little more than nudge radios, shed a faint auroral arc into a camera frame, ask a satellite to take a breath. Some storms wake towns that have never seen such color. Once in a great while, a storm will ask more of us. Readiness, then, is not a posture of fear but of belonging, an acceptance that we live inside a moving system, that our tools can learn the rhythm, that the same star that fills our mornings can, now and then, remind us how wide its reach is. Between caution and wonder, there is a balance we can keep. The watchers continue their quiet arcs. SOHO fixes its gaze. SDO threads the sun's days into a movie of light. Parker skims the furnace and brings back whispers. Solar Orbiter tilts and peers. Hinode and Aditya L1 add their careful notes. Ground telescopes pull detail from air that shimmers. Forecast centers gather all of it and turn it outward as guidance. Engineers fold that guidance into steel and silicon. Astronauts fold it into checklists and drills. And the rest of us stand, sometimes, under a night sky that suddenly remembers color. Someday, a storm will test us harder than recent memory can recall. When it does, the first signals will arrive as numbers on a screen, then as choices made quickly by people who have practiced them 100 quiet times. Lights may dim, routes may curve, machines will ride out the weather they were built to survive. And somewhere, a child will watch a horizon bloom in green and red and call for someone to come and see. None of this makes the sun less wild. It makes us better neighbors to it, alert, adaptable, and still capable of awe, even as we build the lighthouses that keep our coasts safe. Out beyond the blue, astronauts will continue to meet the sun more directly than we do. They will read the same alerts we read, only closer. They will float in small shelters while counters tick and murmured conversation replaces the usual clatter. They will step back out when the numbers fall, return to their work, and carry the story further. In the end, living with a temperamental star is not a contest we win or lose. It is a practice, knowledge gathered, preparations made, technology shaped with care so that exploration can continue and mornings can remain simple. The sun will keep its fire, we will keep our watch. Between them stretches a path we are learning to walk, with caution in our hands and wonder in our pockets, listening for the next quiet bell from the lighthouses we lifted into the dark. The line of fire is daunting, and yet it is also where discovery begins. To leave the cradle of Earth is to accept that the same star that warms our mornings can, at times, bare its teeth. For the people who ride tin-thin rooms into that light, a flare is both a warning and a quiet vow to be ready. For those of us listening from safe ground, their work is a reminder that courage often looks like patience, checklists, and a steady voice over a headset beneath a sky that is never entirely still. The sun keeps a rhythm. From a backyard, it looks faithful, up, across, down, so reliable that our days, our crops, our clocks lean on it without a thought. But when watched carefully, the steady glow reveals a pulse, a long inhale and exhale written in magnetism. That pulse is the solar cycle, a roughly 11-year rise and fall in sunspots, flares, and general temperament. Think of it as a heartbeat slow enough to miss unless you press your ear against the chest of the sky. Sunspots begin the story. They are not bruises or holes, but regions where magnetic fields crowd together, suppressing heat from below and cooling the surface just enough to look dark against the glare. Even dimmed, they are hotter than any forge we've made. They come in pairs and chains, often ringed by bright arcs that loop into the atmosphere like bridges of light. Count them each day and a pattern emerges. Years when the face is busy and freckled, years when it looks bare and calm. In the 19th century, a patient observer named Samuel Heinrich Schwabe noticed the pattern and gave it a shape about 11 years from one peak to the next. Later, scientists found the deeper beat. Every cycle, the sun's magnetic poles trade places. North becomes south, south becomes north. So a full magnetic loop takes about 22 years. We see half the dance in the spots. The field completes the turn behind the scenes. At solar maximum, the stage is crowded. Active regions multiply, loops shine like filigree, and the chances for magnetic reconnection grow. More sunspots generally mean more opportunities for fields to snap and rearrange, and that means more flares and more coronal mass ejections. On Earth, the season reads as brighter auroras, scratchier radio, and a greater likelihood that operators and forecasters will lift their heads from the usual rhythm and pay closer attention. At solar minimum, the face can go smooth for days, sometimes weeks, yet even the quiet years are not empty. Under the surface, flows continue, and fields wind, the way muscles relax even as the heart keeps time, preparing the next rise. This pulse matters in practical ways. Space weather forecasts draw strength from knowing where we stand in the cycle. Satellite teams plan maintenance and safe modes with an eye on the curve. Airlines weigh routes over the poles when activity climbs. Grid operators watch for the slow currents. Storms can pull through long lines. Astronauts, too, read the cycle when plotting journeys beyond the shield of Earth, because frequent flares and particle storms tilt the odds. Climate researchers listen for subtler effects. The sun's energy output wobbles a little across the cycle, small nudges folded into a far larger story here. on the ground. The cycle is not the driver of long-term climate change, but it is part of the background music that careful ears can hear. Deeper still, the cycle offers a window into the sun's engine, the solar dynamo. Inside, hot plasma rises and cool plasma sinks. The equator spins faster than the poles. Magnetic field lines are dragged, twisted, and braided by those motions until they tangle beyond patience. When the stress becomes too much, the field reorganizes, the poles flip, and the counting begins again. The equations are stubborn and the details are many, but the outline is simple enough to hold. Motion feeds magnetism. Magnetism stores strain. Strain resets the map. We watch the spots because we cannot reach the core. The rhythm is not a metronome. Some cycles are loud, others soft. From time to time, the sun slips into long lulls. The Maunder minimum, between about 1,645 and 1,715, saw sunspots nearly vanish from records for decades. Winters in parts of Europe ran colder. Rivers froze that rarely do. It is tempting to lay every chill at the feet of the sun, but modern studies suggest the connection is gentle, not commanding. The lull remains a reminder that our star has seasons of its own, and that those seasons can ripple outward into weather, culture, and memory. Today, the counting is a chorus. Ground observatories track spots across the face. Satellites measure fields and light across many wavelengths. Models attempt to guess the strength and timing of future peaks. A new cycle announces itself with sunspots born at higher latitudes carrying reversed magnetic polarity, little flags that say the turn has begun again. The present chapter, Solar Cycle 25, started in 2019. Early forecasts leaned cautious, but the sun has a way of surprising its readers. Activity grew livelier than expected, and forecasters adjusted their maps, while operators refreshed playbooks, just in case. There is an elegance to this pulse that reaches beyond utility. It gives shape to our star's moods. It helps explain why auroras come in clusters, some winters and not in others, why flares arrive in volleys and then quiet, why the sun sometimes wears a necklace of spots and sometimes goes plain. To listen for it is to hear a kind of breath, slow by human clocks, but vital to the living space around us. Constancy, the cycle whispers, is often an average drawn across many small storms. The steady thing we trust is built from change. Looking outward, our sun is a moderate one. It throws tantrums by our standards, but by the galaxies, those tantrums are small. Other stars release superflares events hundreds or thousands of times more powerful than anything recorded from our own. Space telescopes designed to watch for planets, like Kepler, also watch stars themselves with exquisite precision. And in those long, careful light curves, sudden spikes appeared, hours-long flares so bright they would dwarf our strongest storms. A world close to such a star would feel its sky torn open, ultraviolet and X-rays pouring down, atmospheres heated and stripped, surfaces scoured by particles. Red dwarfs, the most common stars in the Milky Way, are particularly mischievous. They are small and cool compared to the sun, which means their just right zones for liquid water sit tucked close to the star. A planet there circles in days or weeks, but many red dwarfs flare furiously, their magnetic fields twisted tight by their slow, cool fires. Proxima Centauri, the nearest star to our own hosts, a planet in its temperate range, and for a while, the thought of nearby life felt less like science fiction and more like a patient plan. Then Proxima flared, hard and bright, and the calculations grew sober. Even a thick atmosphere and a strong magnetic field would have a long, hard job holding on under such frequent blasts. Other neighbors tell similar tales. A.D. Leonis has jumped in brightness by startling amounts. E.V. Lacerte has thrown flares that, scaled to Earth, would have troubled our species if we orbited there. These are not rare exceptions, but characteristic moods. On such worlds, survival, if it exists, might live under rock or ice, far from the sky. Oceans tucked beneath shells of ice, like the hidden seas suspected on Europa and Enceladus in our own system, could cradle chemistry safe from the stars' shouting. Strong planetary fields and dense air could blunt the worst. Some researchers even wonder if the bursts themselves might, paradoxically, feed the first steps toward life by driving complex molecules to assemble. Creation and destruction share tools more often than we think. Superflares are not confined to red dwarfs. Younger sun-like stars, spinning faster and hosting stronger fields, can erupt in ways our middle-aged star mostly has left behind. It is possible that the young sun played rougher in its early days, testing the patience of a fledgling Earth. Life found a foothold anyway. Whether that is a testament to biology's stubbornness, to our planet's layered protections, or simply to the luck of timing, is still a question worth sitting with. The search for life beyond our world keeps bumping into the tempers of stars. A planet can sit in the right temperature range and still be wrong for life if the parent star sprays it with frequent, fierce radiation. Habitable zone is not a promise. It is an invitation to ask better questions. Does the planet have a field? How thick is the air? How often does its sky light up? The calm moderation of our sun looks more like a gift when set against this broader cast. We orbit a star that sings loudly enough to be interesting and quietly enough to be survivable. That balance may be rare. It is certainly precious. Back home, the frontier still runs through human bodies. Astronauts look at the same sun we do, only closer in spirit. A flare to them is not a headline, but a procedure. Stow tools, close hatches, move into the sheltered place, wait, and listen. The line between danger and nuisance is often measured in minutes of warning. Here, too, the cycle matters, not as fate, but as context. Busy years bring more alerts. Quiet years give training room to breathe. In all years, the sky above the thin blue air remains a place where knowledge becomes safety. The methods for living with a temperamental star are as humble as they are effective. On Earth, grids can be segmented so a surge does not run across a continent. Transformers can be designed to shrug off slow currents. Spare parts can be stockpiled. Satellites can learn to turn, rest, and ride out the worst. Constellations can be built with graceful failure in mind. Forecast centers can keep the watch steady, and when a notice goes outfield, likely southward, arrival in 12 hours, the people who need to act can do so without drama. None of it is grand in the moment. All of it is the difference between a story retold warmly and a night that could have gone otherwise. The cycle that guides storms guides wonder, too. Some winters bring auroras to latitudes that do not expect them. Children in places where the sky rarely sings learn new colors for night. Cameras catch greens and reds at the edge of towns. A pilot arcs south and glances at a soft glow at the curve of the earth. A farmer steps onto a porch and stands longer than the cold would usually allow. The same star that can trouble a transformer will, the next evening, lay light on a quiet kitchen table as if nothing had happened. It isn't denial. It's the way living systems hold both risk and comfort at once. Compared with many suns, Ours is merciful. That mercy is not an excuse to forget. It is a reason to keep learning. The cycle will crest and fall. Flares will flicker and roar. CMEs will miss, will graze, will sometimes arrive squarely. Our tools will get better, our forecasts steadier, our habitats wiser. And through it, a song will keep playing, a verse of spots, a chorus of loops, a bridge of storms, a refrain of calm. We are lucky to hear it from here, on a planet wrapped in field and air, warmed by a star that knows how to be lively without being unlivable. When the mind grows restless, it can help to think of the sun breathing fields tightening and easing, light steadying and flaring, a slow rotation carrying patterns across the face. Somewhere as you read this, a new spot is forming at a higher latitude, a signpost of tomorrow's weather. Somewhere else, a loop is leaning toward a neighbor, preparing a quiet snap that will briefly brighten the corona. Instruments will note it. A forecast will adjust by a small degree. No one will notice on the ground. And still, it all matters. Because this is how we learn to share a neighborhood with a star. The frontier is not only the line where metal meets vacuum. It is the understanding we carry into that line. To accept the sun's dangers is not to fear it. It is to respect the rules of the house we live in. The cycle offers a map. Other stars offer perspective. Our own story offers practice. Taken together, they let us stand under a sky that breathes and say, with a calm that feels earned, this is where we belong. Gratitude sneaks in at the edges when you think about it, how, in the long lottery of stars, we ended up circling one that, for all its tempers and sparks, gives more nurture than harm. The sun has always been our timekeeper and hearth, braided into harvests and myths, into calendars and prayer. In old stories, a bright sun promised grain and calm seas. A hidden sun meant lean years. Modern eyes carry new tools, and with them a new question. When this star throws its quick tempests, flares, and their heavy companions do, those outbursts tug on Earth's climate in any lasting way. The honest answer is quiet. Solar activity matters, but softly, and mostly in ways that need patience to hear. It helps to set two words gently apart. Weather is a mood fast, local, mercurial. Climate is a character, the long pattern, the balance sheet of energy written over decades and centuries. Flares and coronal mass ejections thrill space weather. Radio blackouts here, auroras there. Satellite hiccups, astronauts stepping into shielded corners. Their fingerprints on climate are faint. A single flare, no matter how fierce, does not tilt seasons or redraw average temperatures. To find the sun's steadier influence, you listen not to the pop of a spark, but to the slow drum of its cycles. That drum is the roughly 11-year rise and fall, marked by sunspots. More spots generally mean a livelier star and a tiny uptick in total energy. Fewer spots, a tiny dip. The change is small, about 0.1% in the whole stream of sunlight, and yet even such a nudge can lean on Earth's atmosphere in subtle ways. During long lulls, like the chill stretch in the 1600s and early 1700s, often called the Maunder Minimum, winters in parts of Europe grew harsher, rivers froze more often, and glaciers edged forward. But the story refuses a single cause. Volcanoes were busy, lofting, light-scattering aerosols high into the sky. Oceans shifted their slow circulations. The sun's quiet likely played a part, one thread among many in a woven, changeable cloth. That is the pattern to hold. Solar variability is a supporting character, not the lead, and it often works by amplifying or easing other forces rather than commanding the stage. Myths like simple answers, and it can feel tidy to point at the sun and say, there is the reason. But the measurements do not oblige. Satellites have watched the sun's energy closely for decades, while Earth has warmed quickly. Over that same period, solar output has not marched upward in step. If anything, it has trended slightly down. The warming we live inside matches the rise in heat-trapping gases we release, the signature of our own industry and appetite. The consensus here is not a fragile thing. The sun shapes climate in gentle ways, and the recent rapid warming is primarily our doing. Gentle, though, does not mean absent. The sun modulates slices of light unevenly. Ultraviolet emissions swing more across the solar cycle than the visible band does, and that UV shapes the chemistry of the stratosphere, where ozone lives and works. A change up high can shift the dance of winds, nudge jet streams, and lean on rainfall patterns here and there. Some studies trace hints of the solar cycle in the North Atlantic's winter moods, a suggestion, not a shout, that the sun's breath can be felt in regional weather. The signals are small, braided into noisier stories, but they remind us that the atmosphere is a connected instrument, and a tweak in one register can sound elsewhere. There is also the idea of cosmic rays as quiet cloud makers. When the sun is busy, its wind is stronger and shields Earth better from the high-energy particles that drift in from deep space. Fewer cosmic rays, some argue, might mean fewer seeds for cloud droplets, and thus a slightly clearer, warmer sky. More cosmic rays, the opposite. It's an intriguing mechanism, tested again and again. So far, the effect, if it exists at all, looks modest, more footnote than headline. Interesting, but not the lever that moves the climate we're now changing with our own hands. Stretch the timeline, and the sun's influence becomes undeniable. Over billions of years, its brightness has crept upward. The young Earth lived under a dimmer star and stayed warm enough for water to flow, thanks, likely, to a thicker quilt of greenhouse gases. Far ahead, the same slow brightening will push our planet out of the comfortable zone entirely. On geological scales, the sun is the rulebook. On human scales, the span of cities and crops, of children and grandchildren, its variations are gentle drumbeats against which our choices play the louder tune. This is the difference worth keeping. Flares are dramatic, but brief, the punctuation marks of a restless star. They rearrange magnetism, bend our radio paths, set the sky aglow. They do not steer climate's long arc. The solar cycle adds texture, a delicate pattern you can find if you look with care over decades. Once in a while, a long, quiet pairs with colder years. But the steep rise we measure now is not the sun's doing. There is humility in that conclusion, and responsibility too. The star sets the stage. We are busy changing the scene. Perspective matters because it keeps awe and agency in the same room. The sun breathes, Earth answers, volcanoes speak, oceans carry heat, and slow rivers under the skin of the sea. And we, with our engines and furnaces and lights, tip the scales. It is tempting to pass the burden to a star. The evidence asks us to look closer and hold a more intricate story, one where our fingerprints sit plainly beside the sun's light touch. Hold, too, a different kind of imagining. Picture a day that starts like any other alarm clock. Glow, coffee, steam, a quick glance at the news fed silently through satellite links and fiber. Far above, without drama, a magnetic knot on the sun gives way. In less than 10 minutes, X-rays and far UV pour into the top of our sky. ionizing the thin air and turning smooth radio paths ragged. Ships call into silence on high-frequency bands. Flights over the poles grow uncomfortable with patchy contact. To most of us, nothing yet looks wrong. Then the second act, a massive coronal mass ejection slung outward by the same rearrangement, crosses space in a day or two and meets Earth's magnetic shield with unusual force. Auroras spread far from their usual homes. Green rivers and red veils arc over cities where most have never seen such color. The beauty is real, and so are the stresses. Long lines hum with slow currents they were not built to love. Transformers heat. In control rooms, operators close switches, shed loads, try to keep the grid balanced as the storm leans harder. Satellites ride out the blast in safe modes. Some recover, a few do not. Solar panels carry scars. GPS stumbles, and with it 1,000 quiet services flicker timing and finance. Tractors steering themselves with inch-level precision in wide fields. Ships threading crowded channels. Air travel bends away from the poles, delays stacking like dominoes. Weather forecasts grow coarser just when the atmosphere is being kneaded by high-altitude energy, because the eyes that usually watch from orbit are squinting or blind. None of this looks like a cinematic apocalypse. It looks like fragility revealed. Threads we forgot were there, now tugged at once. Imagine the same scenario stretched further, an eruption far beyond any our sun has shown in recorded history. A mega flare of the kind seen from other stars. The first signal is the same, only larger. A few minutes to radio darkness in some bands. A day or two to the main blow. Auroras ride equatorward. Currents surge through grids. Some transformers fail beyond repair. The map of power blinks. Not neighborhood by neighborhood, but region by region. In a few places, the lights return in days. Elsewhere, weeks go by, while heavy replacements are built and shipped and lifted into place. Satellites are lost outright. Navigation becomes local again. Pumps and payment systems stumble without timing signals, then settle into slower, manual rhythms. Hospitals run on generators. Communities find old muscles, mutual aid. Paper ledgers, the art of making do still work. The point is not to frighten, but to be clear-eyed. Such events are rare. We live most of our years in quieter weather. But rare is not never, and imagining the shape of the day helps. Engineers already think this way. Grid operators practice sectionalizing networks to keep trouble from cascading. Satellite builders harden electronics and design constellations to be graceful when a few members falter. Airlines carry playbooks for polar routes on noisy days. Astronauts have shelter drills that turn dread into routine. Preparation is not glamorous. It is a long, patient kindness we offer the future. In that patience, gratitude returns. Our sun is lively enough to paint and teach and keep us honest, and calm enough to let water, air, and biology make a home. We are not passengers without say. We can read its cycles, build with its moods in mind, and still stand outside at night with our mouths slightly open when the sky decides to write in green. If a great storm comes, it will bring silence of a different kind. The hum of machines dimmed, the rush of messages slowed. In that quiet, what would we learn about ourselves? Perhaps that community is a technology too. Perhaps that progress is not erased by a long outage, only paused. Perhaps that respect for the power that grows food and drives wind, for the star that breathes across our days, is a steadier kind of preparation than fear. Meanwhile, the true climate story keeps its scale. Flares will spark and fade. The 11-year drum will rise and fall. Our star will nudge. our choices will shove. The sun's fingerprints on climate are light and delicate, stitched into a larger tapestry. The myths that try to hand it all the blame miss the quieter beauty. A system where many voices sing at once: stellar rhythms, volcanic ash, ocean sway, cloud and ice, and human breath. Listening properly is slow work. It trades drama for clarity. It leaves us with responsibility we cannot pass back to the sky, and with wonder we can keep. There's a quiet kind of poetry in realizing that the sun, so steady to our morning eyes, is also a maker of sudden fireworks. From the ground it keeps its faithful ritual, slipping over rooftops with a soft gold that makes coffee steam look holy. Yet beneath that gentle light, the star is restless. Its surface is a moving sea of plasma. Its magnetic fields coil, tighten, and snap. Its outbursts bloom into space with a brilliance we can only borrow through instruments. Solar flares are the bright punctuation in that ongoing sentence. Quick exclamation marks written in fire, reminding us that our most familiar star is not a lamp, but a living process. Through telescopes tuned beyond human sight, the scenes turn dreamlike. In extreme ultraviolet, great arches of plasma trace invisible magnetic lines, bright strokes laid down by a painter who works in heat. Loops taller than Earth rise and relax, as if the star were stretching after a long sleep. In X-ray images, the face of the sun looks like a storm-painted canvas knots that bloom and fade in minutes, ripples of intensity moving through a bright hush. The calm circle we glimpse in daylight is, in truth, a cauldron, its surface textured by granules, the size of continents, and shaped by magnetism that never tires. Beauty is braided with fragility. A flare on its own won't scorch the ground or blow away our air, but its reach is long. Light races outward in minutes. Charged particles follow along magnetic highways. Our satellites feel the tap. Long wires on Earth sometimes hum with slow, unwanted currents. Each event is a reminder of the protections we live beneath. The planet's magnetic field, deflecting a portion of the storm, and the atmosphere, softening what gets through. Without those layers, the sun's tempo would be something we felt in our bones. With them, we can watch and prepare, and sometimes step outside to see the sky answer in color. That answer is aurora. Veils of green and red unwinding over dark water and snow. Quiet curtains that blink and ripple at the edge of the world. The same flare that troubles a radio link can send a river of light over a sleeping town. This double truth, danger and grace bound together makes flares hard to look away from. They are both a test of our tools and an invitation to awe. Evidence that we live inside a moving system that, when it chooses, writes poetry across the night. Thinking about flares is also thinking about scale. A strong one releases energy like billions of nuclear blasts, and yet it is only a spark on a star more than 1,000,000 times Earth's size. Enormous to us, ordinary to the Sunday. Still, what begins on that bright surface crosses 93 million miles and brushes our lives, disturbing a signal, shifting a flight path, asking a satellite to turn and wait. Vast power, brief burst, distant consequence. Our days are stitched to that rhythm, whether we notice or not. Long before we had eyes to see them, storms raged on our star. In the deep past, such outbursts may have nudged the atmosphere's chemistry, helping to build the molecules that later learn to copy themselves. The sun's long pulse has been beating through all of Earth's history. We are only recent listeners. Now, with instruments perched above the air, we can watch in detail, light rippling outward, particles streaming into the heliosphere, sudden knots brightening where magnetic fields choose a simpler shape. Fear and admiration can share a room. That we can feel both is a measure of how far fragile beings with glass and metal have come. Humility has a place here. The universe does not arrange itself around our schedules. The sun will flare at noon on a holiday as easily as it will in the small hours of a workday. Our choice is not command, but comprehension. To learn, to forecast, to adapt. In that acceptance, there is comfort. Knowing that our place is delicate makes it feel precious. Knowing why it is safe most of the time makes gratitude easier to hold. We are not shielded by luck alone. Earth's magnetic field and layered air are old achievements, outcomes of molten iron turning and ancient gases settling that now play the role of guardians. In a galaxy where many worlds lose their air to a star's breath, having both a field and a sky this generous is its own fortune. Look around the neighborhood. Mars tells a cautionary tale. Thinner field, thinner air. A surface that remembers water the way a dry lake bed remembers rain. Its atmosphere has been peeled back, molecule by molecule, by solar wind and time. Farther away, planets under harsher stars may never keep a blanket at all. Against that backdrop, our world looks delicate and lucky, at once fragile as a soap bubble, resilient as a forest. When people speak about fire in the heavens, they often mean distant twinkling or a meteor's scratch. But flares are the true fireworks of our sky, hidden from unaided eyes, revealed by lenses that can see heat and ionized gas. They embody the paradox at the center of things. The star that gives us breath can also shout. Each burst is a short message from the heart of the system. I am constant enough for you to plan a life, and I am never still. This is where science and poetry shake hands. Light is not only illumination, it is a message. Radiation is not only hazard, it is a sign of vitality. Plasma loops are not only storms, they are sculptures, drawn in glowing lines by magnetism on a scale that makes architecture blush. You can read a flare as a curve on a graph, and then step outside and feel, somehow, that the world is larger for knowing it exists. Physics does not cancel wonder, it often delivers it. To lie under a clean sky with no idea of what is erupting beyond vision is a kind of shelter. To study those eruptions is to wake up to our star's drama. Both are human. The rest that comes from trust, and the curiosity that gets up to look. And when we reflect, we can hold two truths without breaking them. We are protected by shields we did not build, and we have learned to tend those shields with care. The sun speaks in patterns, pulses of light, bursts of charged particles, cycles rising and falling over years. Its storms are not random tantrums, so much as lines in a longer story about magnetism and motion. Flares are chapters in that story, windows into a deeper process churning beneath the surface. At the center, fusion quietly turns hydrogen into helium, the slow fire that keeps the room warm. But the flares we see are not the furnace itself. They are the language of the outer layers, where plasma moves and fields are made and unmade. Think of a heartbeat. You do not see the cells dividing or the sugar moving, but the rhythm tells you the body lives. So it is with flares. Their timing and shape say something true about the state of the sun's magnetic heart. That heart is stirred by the solar dynamo. Inside, hot material rises and cooler material sinks in convective loops. The equator spins faster than the poles, dragging magnetic field lines along and twisting them into ropes. Over time, the tangle tightens. When it can't be twisted further, the field finds a new arrangement in a blink, and stored energy is paid out as light and heat. Each flare is a small simplification, a knot untying with a bright sigh. Watching these moments has taught us not just about the sun's habits, but about stars of many ages. Youth is loud in the universe. Young stars spin fast and fling their fields around with enthusiasm. They throw super flares that make our sun's biggest shouts look restrained. With age and slower rotation, tempers cool. Flares still come, but they are gentler and fewer. In this way, a star's outbursts are part of its biography. Our own star carries a rhythm we can count. About every 11 years, sunspots increase and fade, a surface sign of a deeper flip as the magnetic poles trade places. When spots are plentiful, flares are frequent. When the face looks nearly clear, outbursts are rare. The cycle is not a metronome. Some peaks are taller, some valleys deeper, but it is steady enough to guide calendars in space weather offices and remind us that the sun, like Earth, keeps a kind of season. Flares are also tour guides through the sun's layered air. Different kinds of light reveal different heights. Radio waves tell of broad, low regions. Ultraviolet shows the chromosphere's quick answers to heat. X-rays whisper of the corona's hottest knots. Stitch these colors together, and the path of energy becomes a map. With each event, astronomers learn a little more about how heat and particles move in that bright atmosphere. The star is writing its autobiography in light. We are teaching ourselves to read. The reading grows richer when we look out to other suns. Red dwarfs, small, cool, and plentiful flare often. Their fields twist tight, and the planets that live in their habitable zones sit close. It is an uneasy neighborhood. Radiation can be fierce. Atmospheres can be stripped. Life, if it finds a way, may have to hide under ice or stone or water. Giant stars, nearing old age, flare less, but their magnetic fields still sculpt their outer layers in graceful, strange ways. Each type of star tells a different chapter. Together, they compose a broader epic about how magnetism ages. It would be easy to treat flares as only numbers, but they carry a more human echo, a sudden idea, a jolt of feeling, a change that arrives quickly and rearranges what follows. These, too, are bursts that punctuate a quieter flow. The sun's exclamation points are not our own, yet the resonance is there. Constancy is built from change, and what looks still is often not. The lessons reach past charts and telescopes into the question of where life can settle. A planet under a flare-prone star may live under a harsh sky. One under a calmer sun may have long, forgiving seasons in which biology can try and try again. Magnetism, it turns out, belongs in the recipe for habitability alongside water and distance and chemistry. Listen to enough stars, and you begin to hear how rare and generous our circumstances may be. The story has touched our history already. The auroras and sparking wires of the 19th century's great storm have their place in our memory. The near miss of a major 2012 eruption has its place in our caution. Spacecraft and observatories keep their watch because the story is ongoing, and we are inside it, not outside looking in. Every alert sent to a grid operator, every satellite put into safe mode, every forecast that saves a pilot a difficult hour is part of the same conversation between a planet and its star. As we venture outward, that conversation grows louder. Flares will dictate when to pause a spacewalk, how thick a wall should be, where to stack water and food to make a shelter inside a ship. Habitats on the moon may wear blankets of dust for protection. Ships on the way to Mars will carry small rooms with heavy walls just for waiting out a storm. Leaving home doesn't end the relationship. It makes attention even more necessary. What makes all of this remarkable is how quietly it is spoken. Space carries no sound. Flares have no voice we can hear. Yet across the distance, through light and magnetism, messages arrive every day. By learning to translate them, we do more than protect circuits and schedules. We learn the language stars use when they tell their own stories. You can think of a flare as a word, a cycle as a paragraph, a lifetime of a star as a chapter, in something much longer than we can read in one sitting. We stand for a moment on a small world and hold a page to the light. The lines are bright, the meaning deepening the longer we look. Somewhere above, a loop is forming. Somewhere else, a knot is loosening. Instruments hum, night comes on, and the sky, calm or colored, keeps breathing. The story doesn't finish. It keeps unfolding, and we keep listening, gently, one quiet page at a time. The sun is more than the center of our sky. It is the quiet narrator of a very old story, speaking in brightness and breath. From where we stand, it feels resolute, crossing the same arc each day, warming the same fields, slipping behind the same horizon. Familiarity softens its edges until it seems like an everlasting lamp hung just for us. Look closer, though, and the stillness dissolves. A star does not sit, it seethes. Its surface is a restless skin of plasma. Magnetic fields thread through that skin like taut cords, coiling and knotting, then snapping free. The corona, its thin ghostly halo, draws itself outward in a steady wind, a long exhale that fills the solar system. Protector and hazard, gentleness and flame, both live together in this one bright companion. Every morning arrives like a promise, and most days the promise holds. Warmth on stone, light on leaves, breath easy in the air. That constancy matters. It lets calendars exist, lets crops learn what a season means, lets people build a whole civilization around a rhythm. But constancy, in a star's language, is made from motion. Granules the size of continents boil up and sink down. Arches of plasma taller than our world rise and fall like slow tides of fire. Invisible fields tangle beneath the surface, tightening until they must change shape. When they do, the change announces itself as a flare, a sudden bloom of light, a brief simplification, a knot untying with heat. This is not a rare accident. It is the regular way of things. The sun's calm is distance painted. Up close, it is always in the act of becoming. And somehow, from this perpetual unease, life receives what it needs. The flow of light feeds the first step of every green thing, turning photons into sugars, and sugars into worlds of appetite and shelter. Oceans hold their liquid because the furnace stays at the right remove. The solar wind, soft most days, stern on a few, helps push back the background drizzle of high-energy visitors from deep space, shaping a shielded neighborhood. There is care here, even though no intention is present, a balance struck by physics that happens to be generous to living chemistry. The same machinery that nurtures us sometimes snarls. Flares and their heavier cousins, coronal mass ejections, are reminders that our star is not tuned to our convenience. A modest burst by solar standards can turn certain radio bands to static. A fast-moving cloud of magnetized plasma, hurled outward like a wave, can jolt Earth's own magnetic field, stirring currents in long wires and making satellites bristle with charge. None of this is personal. A star keeps its rules. We stand nearby with our habits and our delicate systems and learn the art of sharing space with a power that neither notices nor needs us. That is part of the awe, to recognize that we are warmed by something that would be itself whether we watched or not. Between extremes lies the middle ground where we thrive. Too little light and the seas lock. Too much fury and air itself might be peeled away. Earth holds its place in that narrow band, where mornings are possible and storms are survivable. Fragile and miraculous are not opposites here. They are the same description, seen from two angles. The balance can feel precarious, but it has lasted long enough for forests to invent birdsong and for people to invent stories about why the sky behaves. The sun has a patience that we can only borrow for a moment. To a human life, even a modest solar cycle is long. To the star, a cycle is hardly a pause for breath. It turns with a twist, the equator faster than the poles. Its magnetic field flips every time the count of sunspots climbs and falls, north becoming south and back again, with the unbothered grace of a pendulum. There is no rest in this patience, only a smooth continuation. Even when the face looks quiet, few spots, few flashes, the interior keeps winding and unwinding, setting the stage for later drama. We live under it as under an immense, steady hand. Light touches everything, leaf, stone, tide, bone, and in that touching writes the background of history. Empires have risen and vanished under this same radiance. People have planted in faith and harvested in relief, then told myths with the sun as god or guardian or eye. Through all those names, the physical star kept its work. Our stories bent toward it because it is central. It did not bend toward our stories. And yet we have learned to listen better. Telescopes tune to ultraviolet, and X-rays show the loops and knots with clarity our eyes could never manage. Spacecraft dive as close as technology allows, tasting the charged particles, mapping the fields, timing the ripples that race across the corona. We can say with confidence that a flare is not just a bright patch, but the quick release of magnetic stress. We can say that the cycle is not whim, but the surface trace of a deep dynamo, a churning differential rotation that braids magnetism until it must, inevitably, rearrange. Each answer opens a door into rooms we did not know to ask about. Knowledge does not shrink the mystery, it makes it habitable. Flares carry that dual lesson perfectly. They are turbulence, and they are revelation. Dangerous to a thin-walled spacecraft, troublesome to radios and power lines, yet also the authors of Aurora, Green Rivers, and Red Veils that draw people into fields at midnight, heads tilted back, mouths ajar. They are brief by stellar measures and still able to reach us across the gap. To tug on our machines and on our senses. To understand them is useful. To feel them is humbling. Consider how fortunate our circumstance looks when set beside other suns. Many stars, especially the small red ones that fill our galaxy, flare like matches struck over and over. Planets close enough to be warm, lives so near those sparks that atmospheres are a constant negotiation. Some worlds likely lose that negotiation early. Our star sits in a quieter middle, not silent, not safe in every mood, but moderate enough that oceans and weather and biology could weave something complicated. The fireworks are part of the character, not a disqualifying rage. To say the sun never sleeps is to accept two truths at once. The core burns steadily, turning hydrogen into helium with a calm that outlasts civilizations. The outer layers seethe, braiding and unbraiding fields, throwing off light and sometimes storms. Daylight is the calm face. The flares are the confession. Both belong to the same being. And in living beneath them, our place comes into focus. Small, persistent, sheltered often, and tested sometimes, with enough warning to learn and enough time to care. The language of this star is not words, but patterns. A flare is a word, a string of flares, a sentence, an 11-year swell and dip, a paragraph, a lifetime of changes, a chapter in a book too large to hold. We listen with glass and silicon, with coils of wire and sheets of foil, with orbits and patience, and we translate what we can. Carrington's morning sketch of a sudden white light. The ghostly coronas caught by coronagraphs that hide the blinding center so the faint edges can be seen. The streams of numbers from far-off probes, each a little line of the story carried home. Understanding brings a second kind of preparation. Power companies practice how to open switches and reroute load so a geomagnetic surge finds fewer easy paths. Satellites carry habits. Turn away, hunker down, wait. Astronauts know where the best shielded corner is and how to make a small space feel safe for the hours when the counters climb. Airlines bend routes when the poles grow noisy. Forecasts arrive in plain language, and most days they spool by like weather in a place where the sky is calm. This is how a species learns to live with a neighbor that cannot be negotiated with and does not need to be. The lessons stretch into other questions we care about. Where can life begin, and where can it last? A quiet star does not guarantee a garden, and a noisy one does not forbid it. But the temperament of the light matters. Planets with fields and thick air hold their own better. Planets without may lose what they have. Mars knows this story. Its lost warmth is written in dry riverbeds and dust that drifts like memory. Earth's shield is not a trophy. It is a responsibility we bear on behalf of everything that breathes. Time dwarfs us here. Flares lit the corona long before eyes evolved to notice. They will continue when our bones have turned to sand and new names grow on maps we cannot imagine. The sun's cycle will turn, strong and weak seasons altering the shape of aurora and the number of spots. Far ahead, the star will age into a different self, swelling and reddening, changing the script entirely. We know enough now to say that this will happen, and not enough to say, in any human sense, what it will feel like. That is the scale of things. Our part is brief and vivid. Their part is long and patient. If there is a lesson worth keeping close, it is not about fear, it is about attention. Beauty and danger share a source. Chaos can paint. The same flare that asks a pilot to take a longer path will hang curtains of green over a quiet lake and make strangers speak in whispers. The same solar wind that charges a satellite helps push away harsh particles from beyond. The sun's moods are real. So are our capacities for listening and for care. We are small against all this, but smallness is not helplessness. Smallness can be precise, can be steady, can be kind. Think of how a single morning holds the whole arrangement. Somewhere, instruments stare sunward and send home the shape of a new loop forming. Somewhere else, a magnetometer in a quiet field notes a small twitch. Far above, a satellite tilts, then settles. On the ground, a child looks up from a hand-drawn map of the planets and asks a question that has been asked for centuries in 1,000 languages. The answers change, the asking does not. Between them, the star breathes and keeps the room warm. Solar flares began as puzzles and remain so, even as we've learned their grammar. Magnetic reconnection is the heart of it. Lines of force breaking and rejoining. Energy stored in tension, spilled as light and heat. The elegance of it is not diminished by the complexity. A fluid that is also a conductor, a field that moves because the fluid moves, a dance where partners change masks in a blink. No laboratory on Earth can reproduce the scale. The sun offers the experiment and the lesson for free, asking only that we learn how to look. They are also reminders that technology sits on thin ice with grace. Radios crackle, grids hum, clocks drift, screens flicker, and we discover how much our sense of ordinary relies on a choreography of signals. The discovery is useful. It teaches redundancy. It teaches humility. It teaches that the most important systems are often the ones we don't notice until they lean. And still, for most storms, the world keeps going, with a few adjustments and a few stories told later in the language of almost. Walk outside on a cold, clear night, as far from noise as you can manage, and tip your head back. Somewhere on that bright face, a small tangle may be loosening. Somewhere else, a new knot may be forming. You cannot hear it, you cannot see it with bare eyes, but the story is in motion, and you are inside it. The air you breathe, the warmth against your skin, the faint electrical murmurs in the machines in your pocket, all of that is connected to a star that keeps its own counsel and still gives everything it has away. Second by second, what we have been tracing is not a warning label, so much as a relationship. The sun's fireworks are not a separate show. They are the quick gestures of a dancer we know well. The science and the feeling meet there. Lines on a graph and a green river over a dark forest. Equations and a hush that falls on a crowd when the sky decides to move. To learn the physics is to be less afraid. To keep the awe is to be more alive. Long after our last words have faded from the air, the star will keep at its work, burning, breathing, sending stories in light. New listeners will lift new instruments. New myths will find new shapes. The same flares will write their brief letters across the corona and post them on the long road to any world that can read. We are fortunate to be here while this is happening. Fortunate to have eyes. Fortunate to have tools. Fortunate to know just enough to say why the curtains glowed last night, and just enough to admit how much we still do not know. The sun is not silent. It does not use our sentences, but it speaks in patterns we can learn to follow. Watch a little longer, and the restless steadiness becomes clearer. Listen a little more closely, and the old fear gives way to respect, then to a quieter thing that feels like gratitude. Each flare, each aurora, each warm window in the morning belongs to the same conversation. The light takes its time crossing the distance, and when it arrives, it lays itself softly across everything that matters to us. The room brightens. The day begins. Somewhere above, the star keeps breathing. And the story, unhurried, luminous, goes on.